Okay, so let's go ahead and do solving these trig equations using, basically we're going to go over unit circle examples and non-unit circle examples and basically what it means to solve a trig equation. Now, if you remember from any algebra class, algebra 1, algebra 2, even geometry and in college algebra, okay, we were really heavy on solving. Okay, remember that to solve, and I should write solve instead of solving. To solve, okay, it means we go ahead and find the value of an unknown, whether it be X, Y, a smiley face, a heart, whatever it is that you choose to put as your variable, your unknown. That's exactly what we want to look for. All right, and we're going to go ahead and do this using trig equations, which are basically using cosine, sine, tangent, cotangent, secant, and cosecant. And then from there, see how it relates to the unit circle and so on and so forth. So hopefully this video will clarify what you guys should have kind of reviewed the last couple of days. I do apologize that it's taken me a little while to post things. Things have been kind of hectic, but I'm getting the hang of everything. Okay, so let's go ahead and look at unit circle examples. All right, so let's go ahead and look at example 1. Okay, in example 1, we're going to go ahead and have the following trig equation. Square root of 3 times cosecant of 2x minus 2 equal to 0. Okay, now I don't want you to freak out just because you see cosecant. All right, this is just a regular equation. One thing I do want you to keep in mind is that this entire thing is together. Okay, you can't divide by cosecant. That's just not how it works. All right, and what we're trying to solve for, our unknown, is just going to be this x. I want to know what that x is. Okay, now in order to do that, I'm going to treat this equation as if I were solving this one. So in my thought bubble, right, this is what I'm actually looking at. Okay, what I highlighted in blue, I'm just going to think of it as something else. I'm really solving the equation square root of 3 times, and I'm going to put a smiley face, times a smiley face, and I want to know what the smiley face is for right now, minus 2 equal to 0. Now, if we were solving this equation for the smiley face, the first thing you'd probably do is add 2, right? You add 2 to both sides. And you're left with the square root of 3 times smiley face equal to a positive 2. And since I have the square root of 3 times my smiley face and I want my smiley face alone, the next logical step would be, of course, to divide it because these two values are being multiplied. So when I divide by the square root of 3 on both sides, okay, I end up getting something that I can actually work with. And that's exactly what I'm going to be doing when I solve this particular trig equation for x. Okay, take it baby steps. First thing you're going to do, just like we did over here, is we're going to go ahead and add 2. We want to isolate this cosecant of 2x, first of all. So I'm going to add 2x, or I'm going to add 2 to both sides. Okay, remember, both sides of the equal sign, same thing has to happen. Those cancel out, they become 0, and we're left with the square root of 3 times cosecant of 2x equal to positive 2. All right, now cosecant is still not isolated. Okay, that's the first step. Cosecant is still not isolated, so now we're going to go ahead and divide by the square root of 3. Okay, so divide both sides by the square root of 3. These cancel out, they become 1, and we're left with cosecant of 2x equal to 2 over square root of 3. Okay, now, my question now is, what value of cosecant, what does this 2x have to be in order for me to get a 2 over square root of 3 value as it comes from the unit circle? Now, here is where there's a slight little trick. We know that cosecant has a reciprocal, right? Is a reciprocal of something, of a particular trig equation or a trig function, right? Cosecant, this should be in a thought bubble. This is what we should be remembering from like homework 1. Okay, cosecant of any angle is just 1 over sine of that particular angle. So if I go ahead and flip this reciprocal over, okay, or this fraction over, I should get sine, okay? And that's the trick that I'm going to go ahead and apply here. Cosecant of 2x is just the same thing as sine of 2x, okay, except that my fraction, since they're reciprocals, my fraction is also going to be the reciprocal. We have square root of 3 over 2. And what do you know? Square root of 3 over 2 is a value on the unit circle, and it is a value that I can find sign for. Now, all of you guys should have your unit circles. I have mine somewhere right here. Okay, so I can go ahead and show you what I mean. Okay, let me see if I can do the split screen. Yes, I can. All right, so sine of 2x is equal to the square root of 3 over 2. Okay, never mind this 2x. Pretend this 2x doesn't exist. Let's look at the unit circle and see which values, which radian values will give me a sign or give me sine of square root of 3 over 2. If you remember, on the unit circle, your ordered pairs are written as cosine of theta, comma sine of theta. So we're looking for the y coordinate that has a value of square root of 3 over 2. And if we look, we see that right here we have square root of 3 over 2 at pi over 3. Okay, so my angle, this angle, has to be pi over 3 in order for us to get an answer, an output of square root of 3 over 2. Okay, so that's going to be 1. This particular value has to equal to pi over 3 in order for us to get an answer of square root of 3 over 2. Okay, so we have that 2x, and I'm going to put 2x1 because we actually have two places where this happens. 2x1 is equal to square root of 3 over 2. Okay, now what else does 2x have to be in order for you to get an answer of square root of 3 over 2? If we keep going around the unit circle, we see that at 2 pi over 3, we also get a y coordinate of square root of 3 over 2. Okay, so that's going to be another equation we're going to be set up. 2x2, I'm going to put, and I'm putting the subscripts just because I have two potential answers. Okay, and this also has to be square root of 3. I'm sorry, not square root of 3 over 2. Okay, they have to be the angles, my bad. So the first one was pi over 3. I know this 2x has to be equal to pi over 3 in order for me to get an answer of square root of 3 over 2. And the other radian value, I'm sorry, is going to end up being 2 pi over 3. Okay, and then if we keep going around the unit circle, we see that those are the only two places where we get a y coordinate of square root of 3 over 2. Okay, now, if you remember from the previous assignment, these answers are very repetitive. So for example, I can keep going around the unit circle and I can get another answer such that my y coordinate is going to be square root of 3 over 2, right? And this is just periodic, okay? And if we know what the period is for sine, it's just going to be 2 pi. So we're going to add 2 and k pi. Remember that the k is just telling you how many rotations around the unit circle you did, okay, or how many periods you went. All right, and you can do the same thing here, plus 2k pi. All right, so that's the first step, or the next step really. You check which values of sine, so you know what to set this 2x equal to. Which values of sine will give you square root of 3 over 2. Okay, the only thing that was kind of tricky here was going from this step to this step, right? And associating cosecant of theta to its reciprocal so that way you can have an easier time. All right, so from here, we're just going to go ahead and continue solving. We're still solving for x, okay? So we have not isolated x. We have 2 attached to x. All right, so since we have 2 attached to x, we're going to go ahead and divide everything by 2. Divide by 2. Let's work with that equation first. These 2's cancel out, so we're left with x1 equal to pi over 3 divided by 2 is just going to be pi over 6 plus 2k pi divided by 2 is just going to be k pi. All right. And then we're going to go ahead and look at the second equation. Okay, again, we're going to divide by 2. These cancel out. We have that x2 is equal to 2 pi divided by 3 divided by 2 is just going to be pi over 3. Okay, plus 2k pi divided by 2 is going to be k pi. All right, so those are our 2 equations. Now, these that I wrote down here, this equation and this equation are general solutions. So this is when you have an unrestricted domain, or if you just want the general solution, you're just going to add plus k pi. So how often you're going to have a solution, where k is just going to be an integer. So if you remember, an integer is just the numbers on the number line, positive and negative, including 0. Okay, now what if our question said list all solutions in a given domain? So let's say list all solutions from, and let's go from negative 2 pi to 2 pi. Okay, from negative 2 pi to 2 pi. Okay, let's go ahead and do this by doing it in a systematic way. All right, let's go ahead and look at x1 first. Let's see what solutions I can get out of this first equation. All right, do recognize that I have a denominator of 6, okay? And that's going to be kind of helpful. So if I were to rewrite my domain so that I have a denominator of 6, I'm basically going from negative 12 pi over 6 to 12 pi over 6, okay? And you'll see why this makes it easier. That's my domain in the denominator that's given here in x1. Okay, so for x1, and I'm going to list my solutions in curly braces. Okay, I'm going to go ahead and choose values of k so that I can go ahead and substitute it into this equation and see what it gives me and see if it falls within this particular domain. All right, so let's say, okay, let me choose k is equal to negative 2. If k is equal to negative 2, then I have pi over 6 plus negative 2 pi, right? And negative 2 pi, well, this just is equal to pi over 6 minus, right? Positive times negative, right? Plus times minus is minus. Okay, 2 pi is, I already know, negative 12 pi, or 12 pi over 6. So 12 pi over 6, which is going to give us negative 13 pi over 6. Or no, I'm sorry, negative 11 pi over 6. Okay, negative 11 pi over 6. Is negative 11 pi over 6 in this interval? Yes. So we write that the first solution is negative pi over 6. Okay. Next one, let's choose k is equal to negative 1. We have pi over 6 plus negative 1 pi, which is equal to pi over 6 minus, right? If we write this with a common denominator, it's just going to be 6 pi over 6. 6 pi over 6, which is equal to negative 5 pi over 6. Is negative 5 pi over 6 in this domain? Yes. So the next solution is going to be negative 5 pi over 6. Okay. Next one. Okay. Let's say k is equal to 0. We have pi over 6 plus 0 times pi, which is going to be pi over 6. Is pi over 6 in this domain? Yes. So pi over 6 is another solution. Now let's say k is equal to 1. We have pi over 6 plus pi, right? 1 times pi, which is going to be pi over 6 plus 6 pi over 6, which is going to be 7 pi over 6. Is 7 pi over 6 in that domain? Yes. So this is going to be 7 pi over 6. Okay. Let's go ahead and do one more. Let's say k is equal to 2. We have pi over 6 plus 2 pi. That's going to equal to pi over 6 plus 12 pi over 6, which is equal to 13 pi over 6. Is 13 pi over 6 in this domain? No. So we don't have to go any further. Okay. Those are all the solutions that come from the first equation. Now let's look at the second equation. Okay. For the second equation, I see I have a denominator of 3. So let's go ahead and see what this particular domain is. When my denominator is 3. Okay, so I should have negative 6 pi over 3 to 6 pi over 3. Okay. All right, so now let's go ahead and do the exact same thing. Let's see what solutions come from x2. Okay, and we're going to go ahead and choose x values just like we did. K values just like we did with the first equation. So let's say k is equal to negative 2. All right, if k is equal to negative 2, we have pi over 3 plus, okay, or not plus, I'm sorry, minus, I'm just going to do it already, minus 6 pi over 3, which is going to be negative 7 pi over 3. Okay. No, I'm sorry, negative 5 pi over 3. My bad. Negative 5 pi over 3. Okay, and is negative 5 pi over 3 in this particular domain? Yes. So negative 5 pi over 3. Next one, let's say k is equal to negative 1. We have pi over 3 minus 3 pi over 3. That's going to give us negative 2 pi over 3. Is negative 2 pi over 3 in this domain? Yes, negative 2 pi over 3. Next one, if k is equal to 0, we get pi over 3 minus 0 pi, right, which is equal to pi over 3. Is that one in the domain? Of course it is, pi over 3. Then let's say k is equal to 1. Okay, if k is equal to 1, we have pi over 3 plus 3 pi over 3, which is equal to 4 pi over 3, which happens to be in that domain. So that's going to be the next solution, 4 pi over 3. And let's just go ahead and check k is equal to 2. We get pi over 3 plus 6 pi over 3, which is equal to 7 pi over 3, which is not in this domain. So we only have these 4 solutions. Okay, so all of the answers, or all of the solutions to this equation, all right, this square root of 3 cosecant of 2x minus 2, from negative 2 pi to 2 pi are going to be these. We have a total of 8 solutions. Okay, and that's it for a unit circle example. You do have to know how to read the unit circle. It's very, very important. Remember that the first ordered pair is just cosine at this particular radian value. So for example, if I wanted cosine of 7 pi over 6, I know that answer is going to be negative square root of 3 over 2. If I want sine of 7 pi over 4, right, 7 pi over 4, I know I want the y-coordinate, which is going to be negative square root of 2 over 2. Okay, it's not enough to know the unit circle. You have to know how to apply the unit circle. And when I go back, the first thing I'm going to do is quiz you on the entire unit circle. So make sure you know it. You have plenty of time. Okay, so that's one example. Okay, let me do another non-unit circle, or another unit circle example. Okay, so let's say we have 9 cosine or inverse cosine of 2x minus 7 plus 3 pi equal to 12 pi. All right, let me fix this. This looks bad. There we go. Now let's say I want to solve this equation. You might be freaking out a little bit just because I have this inverse. Okay, do not freak out. It's actually much easier to solve an equation like this, okay, than it is to solve an equation like this. And you'll see why. Okay, so again, this entire argument is together. Do not try to divide by cosine or inverse cosine. Okay, you need all of that together. Your unknown is going to be that x value. Okay, not pi. We know what pi is. We know pi is approximately 3.14, right? It's not an unknown value. It's just the way we write it. Okay, so let's go ahead and start solving for x, or start solving for this cosine, what I highlighted in blue, just like we would solve any other equation. Okay, I hope you guys are looking at this problem and thinking, okay, the first thing I need to do is get rid of 3 pi. Okay, and in order to do that, we just have to subtract 3 pi. Don't freak out because there's a pi attached to it. There we go. So now we have 9 inverse cosine of 2x minus 7 equal to 9 pi. Okay, equal to 9 pi. So then after this, we know we can get rid of the 9, I hope. Okay, so we go ahead and divide both sides by 9. This cancels out, it becomes 1. And now we have inverse cosine of 2x minus 7 equal to pi, right? 9 divided by 9 is 1, so we have pi. Okay, now, how do we get rid of that inverse cosine? If you recall, the opposite, or the inverse of the inverse, is just going to be cosine. So we're going to go ahead and take cosine of both sides. So cosine of inverse cosine of 2x minus 7. Okay, and this is going to equal to cosine of pi. Okay, cosine of pi. Now, cosine and inverse cosine cancel out since they're inverses of each other, and we're left with 2x minus 7 equal to cosine of pi. Now, cosine of pi is a value on the unit circle, and if you look at the unit circle, here's my angle, here's pi, so pi. Cosine is the x-coordinate, so cosine of pi is going to equal to negative 1. So this value right here, cosine of pi, is just going to become negative 1. And this is a simple algebra 1 equation that you guys should be able to solve. Okay, we add 7 to both sides. We have 2x equal to 6. Divide both sides by 2. We have that x is equal to 3. And there we go. There's our solution.